When we write carbon dioxide, CO2, the English word here is carbon for the first one. Oh, that's an R. B-O-N-N. Oh, for Pete's sake. Dioxide. Okay? Now, in this case, we don't say carbon oxide with a little 2 next to the O, right? We're actually using a prefix on the oxide to mean that there are 2. When we undergo covalent bonding, so when electrons are shared, they're not given, but shared, which means that when these things split up, they can take their electrons back. In ionic bonding, when a compound that is bonded ionically breaks apart, you can't take back your electrons. They're gone. See you. Okay? But in covalent bonding, it's sharing. Covalent is sharing, which means you can take back. So if we look at carbon, what is the atomic number for carbon? Let's draw an actual carbon molecule. Carbon is in group 14, which means that it's got 4 valence electrons. It's halfway to the 8. Sometimes these elements will take 4 electrons, and sometimes they'll give them up. And if you're giving and taking, that's the same thing as saying that you're sharing. Okay? This is why we often see that carbon as one of the, and you're going to hear me say this time and time again, when we start talking about nutrients, carbon is the backbone of all organic living creatures. Carbon molecules are the backbone of all organic molecules. Sugars, fats, proteins, these are the big 3 different nutrients that make you up. You are full of protein, you are full of sugar, and you are full of fat. Okay? You have all of these. Carbon makes the spinal cord of all of these molecules. So if we look at glucose, okay, glucose has 6 carbons in it. So carbon, 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 carbon. And glucose has different things coming off of the carbon, mostly oxygen and hydrogen. Okay, and I don't remember the order, but I think it's something like there's an H here, there's an H, there's an OH, maybe there's a OH here and an H, so on and so forth. But it's the carbon here that acts as kind of like the spinal cord. Okay, and it's got things branching off of it. And if you look at this, every time you see one of these lines, carbon, like this, it means it's sharing electrons with something else. Okay, methane is a gas. It's a greenhouse gas. The formula for methane is CH4. Well, when we actually draw a methane molecule out, H, 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 and H, we see that what ends up happening here, carbon has 4 electrons. 1, 2, 3, 4. Hydrogen, each of those hydrogens has 1. 1, this guy has 1, this guy has 1, this guy has 1. So now, in this case, the hydrogen has 2 electrons. It's happy, its valence is full. Okay? This hydrogen as well, this one as well, and this one as well. And look at the carbon, holy moly. The carbon, by sharing these electrons, also has 8 electrons. Its valence is full. When this breaks apart, though, that hydrogen is going to say, oh yeah, see you later. I'm taking my electron with me. And it's going to go away. Like it'll be like it had never bonded before. Okay? So if we go back to our image here, now I'm going to draw an oxygen atom. Okay, so I'm going to pause it, take some time, try and draw an oxygen atom. Now, if we look at carbon, how many valence electrons does carbon have? how many valence electrons does carbon have? Count the electrons on the outermost shell. 4. 1, 2, 3, 4. Okay, carbon, come on, wake up, girls. All right, so this has 4 valence electrons. How many valence electrons does the oxygen have? It has 6 valence electrons. What is a total number of valence electrons needed for stability? 8, correct? So if what we end up doing here, okay, what we end up having to do is if these electrons get shared with this guy and these electrons get shared with this guy, everybody has 8. All right? Yes? No? So we end up getting a carbon bound to one oxygen, bound to another, and it gives us CO2. And this is a sharing instance. Okay? So both atoms will be kind of pretending that those electrons belong to them in their valence shell. All right? When this compound breaks apart, this oxygen is going to go away, and it's still going to have its 6 valence electrons, and it will look to bond with something else. Okay? Does that make sense? So, when we go to name covalent compounds, you'll notice on page 13 of your iBook, okay, that you have a table. And it tells you, all right, that prefixes that go on to covalently bonded substances, those occur only when you have covalent bonding. So I don't say magnesium dichloride. Okay, I say magnesium chloride. But, because that's an ionic bond. But when I have carbon dioxide, because it's a covalent bond, I'm going to use that prefix for 2 in front of the second nonmetal, or the second element. The element still gets the IDE at the end. Okay? So in the case of carbon dioxide, carbon, all right, now notice how carbon is a metal or a nonmetal? What? I can have 2 nonmetals bonding together? Well, if they're 2 nonmetals, why is carbon coming before oxygen? Look at your periodic table and see if you can come up with a reason. Carbon keeps its elemental name as is. Now, oxide, okay, the IDE ending, but because this is a covalent bond, we're going to attach that prefix to show that there are in fact 2 oxygens, okay? To actually show that, we put the prefix dioxide. Okay, so that, when you read that, so look at carbon, what do you think this one is called? C bound to just one O. Carbon. If there's only one element, the prefix is mono, right? Mono means 1. Carbon monoxide. Carbon monoxide is poisonous. You can die from inhaling carbon monoxide, right? Okay, so the prefix exists. Okay? So this would be carbon, monoxide. Okay, so mono and then IDE. Di and then IDE.